For question number 1, I need to solve for x. So I need to find the numerical value for x for this particular equation. So let me start by getting rid of the brackets on the left-hand side of the equation. So I notice that there's a 2 here, so we can just distribute the 2 into the brackets. So 2 times 3x will give me 6x. And then 2 times negative 6 will give me negative 12. And then we also have the plus 7 to worry about, equals to, on the right-hand side, I just have a 13 on the right-hand side. After that, we want to collect like terms, so I have my numbers here. Negative 12 plus 7 is going to be negative 5, so negative 12 plus 7 will be negative 5, equals to 13. And then I can add plus 5 on both sides of the equation here. And from here on, I get 6x on the left-hand side, and on the right-hand side, I get 13 plus 5, which will give me 18. And then I can divide both sides by 6, and then from here, you should be able to inspect this and know that the answer here is going to be x equals to 3. So x equals to 3 is your final answer for part A. That's how you solve for x. You find the numerical value in which x equals to. Now for part B, we need to verify that our solution from A works. Okay, so from part A, we did find that x equals to 3 is our answer, right? So we need to verify that this works. So over here, I have an x right there, 3x. So this x is really this x takes on the value of 3, and we know that 3 times 3 is going to be 9. So 9 minus 6 in the brackets. And then I have the 2 on the outside. Plus the 7, and we need to verify that the left-hand side equals to the right-hand side, and the right-hand side has a value of 13. Okay, so if we go ahead and compute the left-hand side, 9 minus 6 is going to be 3, plus 7 equals to 13. 2 times 3 is going to be 6, plus 7 equals to 13, and it turns out that 6 plus 7 is 13, and the right-hand side is equal to 13. So here we can verify that the left-hand side of the equation equals to the right-hand side of the equation. So that verifies that x equals to 3 is indeed an answer to this particular problem, because we just checked it. Okay, so the next few questions in this homework video guide cover the same concept. We need to solve for x, and then we also need to check to see that x works. Okay, so for the next question here, I have a negative 3 here, so it's good to highlight the negative 3 because the negative 3 is being distributed into the brackets here, right? So negative 3 times 4x is going to be negative 12x. And negative 3 times positive 6 is going to be negative 18. And that's going to equal to 26 on the right-hand side, and I also have my 20 on the left-hand side like that. Okay, so sometimes the brackets are kind of in the middle of the problem, sometimes the brackets are in the front of the problem, but you need to get rid of the brackets by distributing. Okay, now you want to look for like terms. I have a 20 and a negative 18, right? So 20 minus 18 is going to be 2, and then I minus the 12x. And that's going to equal to 26. Right, so just be careful with the negative signs here. In order to get rid of the positive 2, I can subtract 2 from both sides. So if I subtract 2 from both sides, I get negative 12x on the left-hand side, and then on the right-hand side, I get 26 minus 2, which is going to be 24. All right, and then after that, we can divide both sides of the equation by negative 12 and negative 12. So negative 12 just cancel off, giving you a positive x, and 24 divided by negative 12 is going to be negative 2. So negative 2 is my answer for x there. So that's a great exercise on being careful with the negative sign. All right, so x equals negative 2. And for part B, we need to verify that our solution from A works. So from A, we found out that x equals to negative 2. And here's my x right here. It's 4 times x, so this will be 4 times negative 2. And 4 times negative 2 is going to be negative 8. So negative 8 in the brackets plus 6. And that's going to equal to 26 on the right-hand side. And I have my 20 minus all that. It's going to be 20. I forgot the 3 there. So 20 minus 3 times all of that. Okay, so if we work on some BEDMAS right here, let's just go ahead and take care of the brackets here. So 20 minus 3 times, well, negative 8 plus 2 is going to be negative 2. Equals to 26. Okay, this will be 20, and be careful here, a negative 3 times a negative 2 is going to be positive 6, and that's going to equal to 26. And it turns out that 20 plus 6 gives you 26, and on the right hand side we also get 26, so 26 equals to 26. We verify that the value of fx equals to negative 2 works because the left hand side equals to the right hand side. Okay, so move on to question number 3, another question where we need to solve for x here. So this time I have 2 brackets now, so I have a 5x there and a negative 15. So be careful when you distribute. So 5x times 3x will be 15x squared, plus 5x times 2 will be positive 10x. And then the negative 15 times the x squared gives you the negative 15x squared. And negative 15 negative 15 times negative 1 gives you positive 15, and that's going to equal to positive 5 on the right hand side there. Okay, so make sure you're okay with the positive sign there, because it's a negative times a negative gives you a positive. And let's go ahead and collect like terms here. I have a positive 15x and negative 15x, so those actually cancel off. 15 minus 15 is 0. And then I have a 10x remaining and a plus 15 remaining there, equals to 5. Well, in order to get rid of the plus 15, I need to subtract the 15 from both sides. And then I get 10x on the left-hand side equals to negative 10. And it turns out that x here, well, if I divide both sides by 10, negative 10 divided by 10 gives you negative 1. Okay, so x equals to negative 1. And we also need to verify that the solution works, so we know that x equals to negative 1. So if you want, you can take a look at the 3x and the x squared. There's a 1 there and a 1 there, sorry, negative 1 and a negative 1. So inside this bracket, I get 3 times negative 1, which is negative 3, plus the 2. And then we also have an x there, so 5 times negative 1 gives me negative 5. Okay, and we have a minus 15. Bracket, and negative 1 squared here means negative 1 times negative 1, which is 1 minus 1 equals to 5. Okay, so a lot of numerical calculations on this question too, so a great question here. Let's do some BEDMAS here. So we know that negative 3 plus 2 is going to be negative 1 minus the 15, and 1 minus 1 is 0 equals to 5. Okay, so this gives me positive 5 minus 0 equals to 5, and it turns out that 5 equals to 5. The left-hand side equals to the right-hand side, so you're good. Okay, so that's it for the equation parts of this homework assignment. Now let's get into some of the linear relations questions. Okay, so for question number 4, Tom has $30 in his bank account, and he saves $5 every week. Okay, so I need to complete the sequence below for the next 5 years. Okay, or the next 5 weeks, sorry. So I guess this is what we start off with. So this is like your starting point. And then I guess this is kind of like your week 1, week 2, week 3, week 4, and week 5, right? And we're saving $5 every week. So this is kind of like an arithmetic sequence here. So in week 1, you'll now have $35, then $40, $45, $50, and $55. Okay, so a simple arithmetic sequence to get started there. And for part B, we need to fill in the table below. So at the beginning, at 0 weeks, or at the start, the question did say that Tom has $30 in his bank account, right? And then after every week, you save $5, so that'll be 35, 40, 45, and 50. Okay, so the table of values and the arithmetic sequence are kind of similar. They're just presented in a different manner. Okay, so write an equation for the amount of dollars saved. The amount of dollars saved, which is y, given by the number of weeks x. All right, so this question is pretty much asking you to write the equation in terms of y equals to mx plus b. So we definitely have seen some of these questions already, especially in the visual patterns part of this spiral here. So there's a few ways you can do this. Here's how you can do it logically. You start off with $30, and you're going up by $5 per week. All right, and that would equal to the amount of money that you have. All right, so you can kind of think about logically like that, and then you can just rearrange this to give you 5x plus 30, and that's one way you can kind of do this question right from the get-go. Another way that you could do this particular question is that you need to recognize that every single time you're going up by 5. All right, so every week you're going up by $5. If you're going, so every 1 week you're going up by $5. So this is really your slope. Your slope is 5. So when you have y equals to mx plus b, you have to recognize that the b value is 5 because you're going up by $5 per week. Okay, and then you got to figure out what b might be. And what I tell students to do is figure out what's happening with x. Let x be, I don't know, 2, right? So what's 5 times 2? Well, 5 times 2 is 10. And what do you have to do to 10 to get to a 40? Well, 10 plus 30 would give you the 40, right? So this is another way where you can get your equation, right? Once you know that you're, so that's one way you can think about in terms of just crunching out the numbers. But once you know that your slope is 5, I mean y equals to 5x plus b, another way you can kind of get the equation is by kind of looking at the y-intercept here. So when x is equal to 0, this is your y-intercept, right? So that's also just 5x plus 30. All right, so there's a few ways where you can kind of get the equation by examining the data in your timetable there, or your table of values there. Okay, explain what the y-intercept and slope mean for this problem. So classic question that you will generally get for these kind of questions. So I guess at the beginning you start out with $30, right? So the y-intercept is your starting, I guess we can say dollar amount. This is how much money you have to start off, which is $30. You have $30 before you start saving. And what does the slope mean? Well, the slope here is 5, right? And the slope, so for sure, let's just write that down. We know the slope is going to be 5, but it's really 5 over 1, right? 5 divided by 1 is 5. And what this really means is that every 1 week, all right, so every 1 week, you save $5. Okay, so that's what the slope means. It is 5, but you have to explain that every 1 week you earn $5, right? That's what the slope means for this problem. All right, sketch your graph below here. Okay, so let's just put the dollar signs here. Let's put the weeks here. Okay, if you weren't sure why is dollar signs by weeks, well, time is always your x value and y is the amount that you're measuring. So if you look at your timetable here, or your table of values here, this is x and this is y. All right, so x is always your time. Okay, so our y-intercept was 30, right? At 0 weeks. So at the beginning we have $30. Then after 1 week, I guess we have $35. And then after 2 weeks, I guess we have roughly $40. And then after 3 weeks, I guess we have $45, right? So we've got to just kind of do our best to sketch that. So I'll just do a few points there, right? So here's my sketch of my graph here to roughly kind of say that, oops, maybe I'll move that 3 weeks over here. So my graph isn't to scale, but this is the general idea here, right? So you guys showcase that you need to show that you have the y-intercept right there, and you need to show a dotted line here because we're measuring this thing in terms of weeks. All right, so every 1 week you're going up by $5. Okay, how much money does Tom save after 12 weeks? Well, okay, we have y equals to mx plus b. We know the slope is 5. We know the number of weeks is 12, and we know the y-intercept is 30. Okay, so 5 times 12 is going to be 60 plus 30. I guess Tom would have $90 after he saves for 12 weeks. Okay, that's it for that one. And yeah, let's move on to question number 5. One more linear relations question here. Okay, for question number 5, you buy a roll of ribbon for wrapping presents. It says it's 35 meters long. All right, so yeah, 35 meters long of wrapping paper, I guess. And in this problem, I guess you have wrapped 8 identical gifts, each requiring X meters of ribbon. Okay, so a lot going on in this particular problem. The very first thing we have to do is write an equation that calculates the amount of string remaining, which is represented by the y variable, after each gift required X meters of string. Okay, so this is actually quite a challenging problem that you need to take a little bit of time to read over. And I guess y represents the remaining string, so that's y equals, so y is the amount of string left over. We know we have 35 meters of string to start, right? That's the amount of meters of string that we have to wrap presents. So we have 35 meters of that, but every time we wrap a gift, we're losing string, right? So our roll of ribbon, you know, is 35 meters in length, but every single time we wrap a present, that 35 meters of length goes down, right? Okay, so we're wrapping eight gifts here, so I guess we're just gonna wrap 8 of them, and each of those 8 gifts is going to use a certain amount of string, right? Okay, so if we have 8 gifts, and if this X value is 1 meter, what that would mean is that we will have used a total of 8 meters of string, so 35 minus the 8 will give you the amount of string remaining. If this thing was 2, for example, each gift takes 2 meters of string, so 8 times 2 is 16, then we would need 16 meters of total string, and then 35 minus 16 meters would give us the remaining string that we have in our roll of ribbon. Alright, so that's the kind of the storyline translated into an equation for this particular problem. Okay, so let's go ahead and figure this out now. Part B is fill the table of values based on your equation, alright? Okay, so the first X value is 0. Okay, so what that means is this X value is going to be 0, right? So if I do some side calculations here in purple, it's going to be Y equals to 35 minus 8 times 0, which gives me 35. Okay, the next value is 1.5, and 1.5 is really 3 divided by 2. So if I go back to my equation here, I can write this as 8 times bracket 3 divided by 2, and then we've got to figure out what this will be. This will be 35 minus 8 times, what I usually do is I usually do this, 8 divided by 2, which is 4, and 4 times 3 is going to be 12. Okay, so a little bit of calculations here. So 35, you got to figure out what 35 minus 12 is, and I guess I'll give you 23. So we have 23 meters of string left. Okay, the next value is going to be 3. Okay, so I'll change this and we'll put a 3 here now. So 8 times 3 is going to be 24. So 35 minus 24 gives you 11 meters of string left. Okay, now we have 4 now, so I'll just change this to a 4 here. 8 times 4 is 32. So 35 minus 32 is going to be 3 meters of string left. Okay, so if each Christmas gift or each present is 4 meters of length or requires 4 meters of wrapping paper, if we use 4 meters each time, we're almost done the roll here, right? Okay, and then we also have 6 now, and I can tell that 6 is probably not going to give us a great answer, right? So 8 times 6 is 48, and then 35 minus 48 is going to be negative 13. So this one's a weird answer, right? We have negative 13 meters of wrapping paper left, which doesn't make a lot of sense, right? So I think that what that really means is when we're wrapping these 8 gifts, you know, you can't use 6 meters of wrapping paper for each gift. Okay, so part C is determine the value of y when x is 12. Okay, so another calculation question here. So y equals to 35 minus 8 times 12. And y would equal to 35 minus, well, 8 times 12 is, this is a weird answer, right? So 8 times 12 is going to be 96. And if I do a 35 minus 96, I get negative 61. Negative 61 meters of roll paper, which doesn't really make sense. Okay, so once again, I think that what this is meaning is you cannot use 12 meters of wrapping paper for these individual gifts here because you just don't have enough wrapping paper to do that. Part D, determine the value of x when y is 22. Okay, so let's go ahead and write y equals to 35 minus 8x. And now we know that y is going to be 22, so put a 22 in for y. And this would be 35 minus 8x. Okay, I have a 35 here, so we can subtract 35 from both sides, right? So if I subtract 35 from both sides, 22 minus 35 is going to be negative 13 equals to negative 8x. And then we can divide both sides by negative 8. And if I go to my calculator here, 13 divided by 8, we get 1.625. Okay, so you can go to a calculator there and get 1.625. So a negative divided by negative gives you a positive answer. Perfect. Okay. What is the value of the y-intercept and what does it represent in real life? Okay, so what's the value of the y-intercept here? Okay, so if I go back to my table here, you have to recognize when x is equal to 0, that's when you have your y-intercept, right? So if I take a look at this graph here, it's like we start off with 35 meters of wrapping paper here, and the y-intercept here is the starting amount of, I guess, wrapping paper. Which is 35 meters. Value the slope, and what does it represent in real life? Well, I know that the equation is 35 minus 8x. And if I rearrange this, I guess I get negative 8x plus 35. And it turns out the slope is negative 8. Okay, so what does the slope represent in real life? Well, if you think about this number here, it's really negative 8 over 1. And what that means is if one of the gifts takes 1 meter of wrapping paper, what that means is for the total amount of 8 identical gifts, I need to use 8 meters of total wrapping paper that's going to be used up. Okay, so that's what the slope means. Okay, so yeah, 8 kind of represents like the total amount of identical gifts, and it represents the amount that we're going to be losing in terms of the wrapping paper, depending on how many meters of wrapping paper we use for one particular gift. Okay, so you know, if I change the x here to be 2 meters, meaning that every single gift takes 2 meters, then the slope will multiply that by 8. And what that means is we need 16. So I'm going to put minus 16 because we're going to use up 16 meters of wrapping paper to wrap up the 8 gifts. Okay, so that's what the slope means. Sorry. Okay, so for part G, what are the possible values for x and y, and why don't other values make sense? Okay, so just think about the graph here. So, I mean, the y-intercept we concluded was 35 meters. We have 35 meters of wrapping paper to begin with, and every time we wrap gifts, I mean, the amount of wrapping paper left kind of goes down, right? It's going down. So we got to figure out what values of x and y make sense. So for y, I mean, y is not too bad to figure out, but let's just go ahead and find the x-intercept first. So I have y equals to 35 minus 8x. If you want to find the x-intercept, which is right there, we will set y equal to 0. If I bring the negative 8x across, I get positive 8x, and I get 35 here. If I divide both sides by 8, once again, you can kind of go to a calculator here, and 35 divided by 8 gives me 4.375. So this value here is really 4.375, comma 0. And if you want, you can also label the y-intercept as 0, comma 35. Okay, so the y values, I mean, it can be any numbers between 0, and 35. So y can really take on any values from 0 to 35. Right, that's the amount of string that's in the original, like the amount of string that's kind of available in the roll of ribbon, right? So it's 35 meters long, so you can have a maximum of 35 meters or a minimum of 0 meters, meaning you've used up all the wrapping paper, right? So those are the possible values for y. And for x, I guess the possible values of x are, 0, and then 0 all the way to 4.375, right? And what this really means is this 4.375 meters. What that means is one of the gifts can use up 4.375 meters of wrapping paper. And since you're wrapping 8 of them, if you use 8 times 4.375, you put that in your calculator, I'm pretty sure you'll get 35 meters, right? So if you had to kind of use up the wrapping paper evenly for all 8 gifts and use up everything, what that really means is the maximum amount of meters you can use for one gift is 4.375. So anything from 0 to 4.375 would work.